The clean answer that lost the clue. The strange part is not that the system gets something wrong. The strange part is that it sounds most organized right before it forgets the thing that mattered. Picture a normal workflow. You give ChatGPT a detailed instruction, maybe a rule about upload order, format, audience, or what must never be skipped. The first step lands perfectly. The answer is clean. The dashboard flips to a green check. Everything on screen says, progress. Then you ask for the next move. And suddenly, the detail that made the first step work is gone. Not loudly gone, quietly gone. The system still sounds helpful. It still uses the right tone. It may even repeat the project name, the goal, and the general plan. But the one load-bearing clue has slipped out of the answer. That is the failure mode worth noticing. A messy error is easy to distrust. A clean answer with one missing constraint is harder because it feels like continuity. It feels like the system understood the workflow and is now moving efficiently through it. But maybe what you are seeing is not understanding. Maybe it is compression. The model has turned a complicated situation into a shorter working version of the situation. And that shorter version looks smooth until you ask it to make the next decision. This is why the timing feels so strange. The first success creates confidence. The interface confirms motion. The next response sounds like it belongs in the same sequence. But underneath that surface, context may already be getting thinner. The question is not just, why did the system forget? The sharper question is, why does the system sound efficient exactly when it is becoming less grounded? That first miss matters, because the next step is to watch where the clean surface starts hiding the real system. A green check tells you a step completed. It does not prove the clue survived. A polished answer can still be running on a thinner version of the task. The relieving reframe is simple. Clean output is not the same thing as reliable reasoning. Efficiency is a compression story. The screen looks simple because the system has already made the hard part invisible. Picture the workspace after a first good answer. On the left, there is a long instruction. Keep the long form upload ahead of the shorts, preserve the channel rule, do not advance the schedule until the blocking step clears. In the center, a green check says the first result succeeded. At the bottom, a tiny follow-up says, great, now continue. To a person, those three things belong in a hierarchy. The original rule controls the workflow, the green check confirms one step, and the follow-up asks for the next move. To a language model, all three are pieces of context competing for influence on the next answer. That is the map. A large language model is constantly compressing a messy situation into the next useful move. It reads the instruction, the previous answer, the latest prompt, the visible status, and the pattern of what usually comes next. Then it has to decide what matters most right now. Some details get carried forward. Some details fade into the background. Some details are still technically present, but no longer strong enough to steer the decision. This is where efficiency gets dangerous. Efficient does not just mean faster. It often means the system is making quiet choices about what can be dropped. If it drops a repeated greeting, nothing breaks. If it drops a formatting preference, the answer may only look a little different. But if it drops the load-bearing constraint, the whole workflow can move in the wrong direction while still sounding organized. That difference is hard to see from the decision surface. The screen shows a clean reply, a completed step, maybe a tidy summary. The hidden state is messier. Which rule is still active, which cue is being overweighted, which earlier sentence has become weak. The missing context does not announce itself as missing. It just stops applying pressure. So the useful frame is not, the system forgot everything. It is more specific than that. The system compressed the situation, and one important piece became too small to control the next move. Once the pipeline is visible, the next move is not another overview line. It is a closer look at the first simplification the system keeps hiding in plain sight. The first success becomes a shortcut. The trap usually starts with a correct answer. Picture an operator screen with one instruction at the top. Group each request by channel, but never move a short clip ahead of the long video it depends on. ChatGPT handles the first item perfectly. It keeps the rule, explains the decision, and the result looks disciplined. The team relaxes because the system has shown that it understands the workflow. Then the second item arrives. Same channel, same style, one slightly different condition. The answer still sounds efficient. It uses the same crisp wording, the same confident sequence, the same helpful tone. But now the hidden rule is missing. The short clip moves forward, because the model is copying the shape of the first success, instead of rechecking the constraint that made the first success correct. That is the shortcut. After one clean result, the system may treat the successful answer as the strongest clue in the room, not because it has a human memory of being right, but because the recent pattern becomes very attractive. The wording worked. The structure worked. The output looked complete. So attention starts leaning too hard on that successful cue and makes it feel larger than it is. The important part is that the failure does not look like confusion. It looks like momentum. On the decision surface, everything seems aligned. Task completed, next step generated, no visible error. In the hidden state, the model has quietly downgraded the original rule from "this controls the workflow" to "this was probably part of the previous example." That creates a new burden for the operator. You cannot just ask, "Did the first answer pass?" You have to ask, "What did the system learn from passing? Did it preserve the rule, or did it preserve the vibe of the rule? Did it keep the actual condition, or just the clean formatting around it?" This is the usable reframe. The first success is not proof of stable understanding. It is a cue that can help the model, or it can pull the model off course. The miss begins when the system sounds smoother, because it is carrying less. And that is only one layer of the pattern. The next layer is why the interface makes this shortcut feel even more convincing. The interface rewards motion. The screen is doing a small trick before the model has made its next mistake. Picture the operator view after a ChatGPT workflow finishes step 1. The reply lands quickly. The spinner disappears. A green check appears beside complete. A generated summary condenses the exchange into 3 neat lines. The progress bar moves forward, and nothing on the surface looks uncertain. If you are scanning that screen under time pressure, the product is telling you one thing: motion happened, so confidence is allowed. But the memory of the workflow is not rewarded the same way. The key constraint may still be present somewhere in the transcript, or preserved in a log, or implied by the first answer. It just does not get the same visual treatment as completion. The interface makes the decision surface look clean, while the hidden state is harder to inspect. What advanced? What was remembered? What was dropped? Those are not equally visible questions. That is the silent trade-off. Product design is often built to reduce friction, and reduced friction feels like competence. Fast replies feel decisive. Checkmarks feel final. Summaries feel like understanding. A tidy queue makes the system look organized even when one fragile detail has quietly fallen out of the active frame. The missing context has a cost, but the cost is delayed. The reward for speed appears immediately. Now imagine the clean operator screen. At the top, every target is aligned. One card says draft prepared. Another says metadata complete. The next button is enabled. Below the fold there is one metric: constraint carried forward, failed. No alarm. No red banner. Just a small line. The operator has to scroll to notice. In that setup, the burden shifts onto the human. The system has not proven that it remembers the rule, but the interface has already started behaving as if it does. This is why workflow confidence can arrive before the system has earned confidence. The problem is not only that the model forgets. It is that the surrounding product can make forgetting look like progress. The useful check is simple. When the interface says done, ask what kind of done it means. Did it finish an output, or did it preserve the condition that makes the next output valid? That distinction lowers the temperature. A clean screen is not proof of a clean memory. And once that hidden mechanism has a name, the next layer becomes easier to see. Context can be attached to a system without being understood by it. Context is not cargo. A full context window can still make a thin decision. Picture the screen after the first step succeeds. The project document is open. A retrieval panel says 3 relevant notes were found. A pasted constraint sits right under the prompt. Do not advance the shorts until the long-form upload has been accepted. To the operator, the evidence is there. The rule is visible. The system has the ingredients. But context is not cargo. You cannot just load more of it onto the prompt and assume the next decision understands what matters most. Retrieval is simpler than it sounds. It brings likely useful information back into view. It can pull in the production plan, the upload receipt, the scheduler note, and the user's warning. What it does not automatically do is assign authority. One sentence may be background. One sentence may be evidence. One sentence may be the rule that blocks the next action. The model still has to decide which one controls the move. That is where the uneven interpretation begins. Short one is rendered, sounds actionable. The 0200 slot is available, sounds timely. The long-form upload is still pending. Sounds like a status detail unless the system ranks it as a stop sign. Nothing has to vanish for the workflow to break. The constraint only has to become less important than the cleaner, more recent, more clickable signal. This is the small error with the large consequence. The answer can mention the long-form upload, cite the retrieved plan, and still prepare the shorts too early. From the outside, that feels irrational. How did it ignore the thing it just repeated? From inside the mechanism, the problem is ranking. The sentence was present, but it was not treated as decisive. So the operator's check has to change. Do not only ask whether the document was attached. Do not only ask whether retrieval found the right source. Ask which line is allowed to stop the next step. Ask what the system thinks overrides what. Extra context is not the same thing as understood context. Useful context is context with priority. And once the wrong priority gets chosen, the next failure becomes harder to spot, because it will not sound broken. It will sound cooperative, concise, and ready to help. The failure looks like helpfulness. The hardest failure to catch is the one that sounds like it is helping. Picture a production queue after the first upload target succeeds. The long-form video is supposed to be the anchor. If it fails, the shorts should wait. But the next ChatGPT reply says, "Great, moving on to shorts." Because the visible surface now contains a success signal, a clean checklist, and a workflow that looks ready for the next item. The hidden state is different. The actual constraint was not, make progress after anything succeeds. It was, do not let shorts advance unless the long-form upload for that run was submitted successfully. That distinction is small on screen and huge in operations. This is where helpfulness becomes camouflage. A wrong answer can be cooperative, concise, and product-aware. It can mention the right dashboard, use the right terms, and still make the wrong decision. It may summarize the policy as if it were a meme, long first, shorts later. That sounds correct, but it has thrown away the control logic, which long video, which run, which channel, which submission state, which cooldown window. The summary is memorable, while the real constraint is conditional. That is a plain version of hallucination, not a bizarre invented fact, not a sci-fi glitch, just fluent output without enough grounding. The model has enough language to sound aligned with the workflow, but not enough active grip on the sentence that should control the next action. It is answering from the shape of the task, instead of the load-bearing rule inside the task. The burden then shifts to the operator at exactly the worst moment. When the answer is messy, people inspect it. When it sounds efficient, people promote it. They click approve, cue the next target, or trust the generated recap, because nothing feels off. The failure is not only that context is disappearing. It is that the decision surface keeps looking clean while the hidden state is losing its map. The usable check is simple. Pause before fluency turns into trust. Ask what fact the answer is now acting on. If it says continue, continue from what? If it says retry, retry based on which timestamp? If it says summarize, did the summary preserve the condition or just preserve the vibe? That question makes the pattern smaller. A confident answer is not the decision. It is evidence to inspect. The next layer is building systems that do this inspection automatically, with context accounting that shows what was preserved, what was ignored, and which successful step is not allowed to rewrite the plan. The next layer is context, accounting the next version of this failure will not be fixed by making the answer arrive sooner. It will be fixed when the system can show what it kept alive. Picture the dashboard after a clean first step. The upload is marked complete. The summary reads well. The next action is waiting, but next to the green check there is a context ledger. One column says preserved, channel cooldown, long-form prerequisite daily slot. Another says ignored, optional phrasing, old draft notes, irrelevant metadata. A third says unresolved, assumption made after one success, still not proven. That is the next layer, context accounting. Not a bigger prompt, not a more dramatic model, just a visible record of what the system believes still controls the plan. The constraint is that memory has a cost. Every preserved rule competes with speed, interface simplicity, and the pressure to keep the workflow moving. The silent trade-off is that many products make this cost disappear from the screen. The reply looks tidy because the messy part was compressed away. Then the operator inherits the check burden. They have to notice that a successful first answer did not cancel the original rule, that a short's task is still blocked by the long-form upload, or that a confident summary has quietly dropped the condition that mattered. A stronger system would interrupt that motion earlier. It would say stale assumption. This plan changed after one successful step, but the prerequisite has not changed. It would block the next action and show why. It would make the missing constraint visible before the model turns it into a smooth sentence. The long-term shift is from output automation to traceable decision memory. Teams will ask less, how many answers did it generate, and more, which facts survived compression when the workflow got busy, which rule was allowed to govern the next move, which success was treated as evidence when it was only one completed step. This is the usable second. When the system sounds efficient, do not only read the answer. Inspect what it now thinks it is allowed to forget. That is why fast systems need slow checks. Fast systems need slow checks. The most dangerous moment is often the cleanest one. One green check, one fast answer, one quiet assumption that the hard part is over. By then, nothing on the screen looks broken. The first step worked. The file rendered. The upload was accepted. ChatGPT followed the instruction once. The dashboard has that calm, efficient look products are built to create. But the question is not only what succeeded. The question is what the system learned from that success. A fast system has to compress. It cannot keep every sentence glowing with the same weight forever. So it keeps the result, keeps the visible progress, keeps the style of the last good move, and starts treating the missing detail like background noise. That is why the next decision can fail without feeling dramatic. The context did not vanish with an alarm. It became less important inside the machine. This is the operator burden. After the first successful step, pause before you trust the second. Ask what rule made the first step work. Is that rule still controlling the next step? Or is the system only repeating the shape of success? If a long-form upload had to clear before the shorts could move, check that dependency again. If a pasted constraint changed the answer, check whether it still has authority. If a summary replaced the source, check what it smoothed away. The practical lens is simple enough to use under pressure. Success is not permission to forget. A green check proves one action happened. It does not prove the next action understands why it happened. That is where slow checks earn their place. They are not anti-automation. They are the part of automation that refuses to confuse motion with memory. Fast systems sound efficient when they move quickly. Reliability begins at the point where speed stops pretending.